Okay, hello. So I would like to talk about this formula. Um, that formula x is equal to pb to b prime x prime. What do we mean here? So we are in a linear space A. Let's take some example with E is equal to R3. That's really going to be the easiest to illustrate. And we've got the first thing is that we have two bases. First base with vectors E1, E2, E3. Let's take a space of dimension 3, so you know you've got three basis vectors. So for instance, in R3, we can take that our first basis is the standard basis, 1, 0, 1, 0, 0, 1. Okay, and we've got a second basis, B prime. E1 prime, E2 prime, E3 prime. Okay, we can take B prime is equal, I don't know, let's take something simple to work with. Let's take this one, 1, 0, this stuff, and negative 1, 1, 0. I've just made that up. How can I check that I indeed have a basis? I need, so that would be E1 prime, E2 prime, E3 prime. If I want to be sure that they make a basis, you know that I have to show that they are linearly independent and are spanning. As I already have three vectors, I just need to show only one of the properties, and the easiest one in that case would just to show that it's linearly independent. Or the way show that it's linearly independent, you have to remember from semester 1 of this year that you just need to calculate the determinant of the corresponding matrix. Okay, if you calculate the determinant of the corresponding matrix and the determinant is different from 0, you should get that the rank of the system is 3, and so we've got 3 linearly independent vectors in dimension 3. So, so that makes a basis. So what do I have? Plus would have minus 2 times 1 times 0 plus 2. Plus 1 times 1. So that's different from 0. Fine. So I've got, I really have a good choice of basis here. And what do we have here? Usually you see that what it means for E1 prime to be equal to 0 to 1, it means that it's 0 times E1 plus 2 times E2 plus 1 times E3. That's my, because E1, E2 is 3 is the standard basis, okay? So that's 0 times 1, 0, 0 plus 2 times 0, 1, 0 plus 1 times 0, 0, 1. Okay, that makes your vector. So usually this is what you have. You have that your new vector, your vector of the new basis, if this is what I'm calling the new basis, and this is the old basis. This is just a name, maybe to help you remember what we are doing here. So E1 prime will be given as linear combination of the vectors of B. So E1 prime is going to be, according to the notations I've used, alpha 1, 1 E1 plus alpha 2, 1 E2 plus alpha 3, 1 E3. Same thing for the other two vectors. E2 prime is going to be alpha 1, 2 E1 plus alpha 2, 2 E2 plus alpha 3, 2 E3, and E3 prime 1, 3 E1 plus alpha 2, 3 E2 plus alpha 3, 3 E3. Okay, usually this is what we have. We have the description of the vectors of the new basis in as a function, as a linear combination of the vectors of the old basis. Okay, all right. So this being said, what else do we know? We know that as both of these systems are bases, I know that any x in E can be written as linear combination of any of the basis vectors. Okay, so that means that x in basis B will be written as x1 E1 plus x2 E2 plus x3 E3. Okay, same thing here. So let's back to our example in R3. Any x in R3. X has components x1, x2, x3. It's really x1 times E1 plus x2 times E2 plus x3 times E3. Okay, this is really what it means. So that would be in my standard basis B. But you know, as we've got also a basis with B prime, I know that I have a unique decomposition as a linear combination of vectors of B prime. So that will give me x1 prime, E1 prime plus x prime 2, E2 prime plus x prime 3, E3 prime. Okay, and this x1, x2, x3 or x1 prime, x2 prime, x3 prime, they are really unique decomposition. Okay, and same thing, I would like to express x in basis B prime as x1 prime, x2 prime, x3 prime, okay, which would be x1 primes e1 prime plus x2 prime e2 prime plus x3 prime e3 prime. Okay, and usually it's very easy to we know this. Okay, this we know, and we want to find this. Okay, but we won't be able to find it directly. We will have to use some kind of indirect information, all right, to get that. Let's see what we know. What is the, so what do we know? What are the things that we know? We know expression of new vectors as function of the old vectors, and we know that this expression exists, okay? This expression, I can write this expression. So what does it mean? If I keep on writing that, I get x prime b is equal to x1 prime, and I'm going to use the expression of e1 prime as a function of the old basis vector. Okay, so times alpha 1 1 e1 plus alpha 2 1 e2 plus alpha 3 1 e3. Okay, I can go on in black. Same thing plus x2 prime times, I will express e2 prime as using its expression with respect to the old basis vectors. So alpha 1 2 e1 plus alpha 2 2 e2 plus alpha 3 2 e3 plus some stuff for x 3 prime times alpha 1 3 e1 plus alpha 2 3 e2 plus alpha 3 3 e3. Okay, similarly here, this is what I have. I've got here I've got x1 prime is equal to sorry, not x1 prime. I've got that x in basis B prime will be given by also by x1 prime times e1 prime, but this is knowing that e1 prime is actually 0 to 1 plus x2 prime times e2 prime, which was 0 1 0. No, sorry, 1 0 2 plus x3 prime times my negative 1 1 0. Okay, so what do I get? I get that that thing can be also expressed as if I'm summing all these, that's going to be 0, 2x1 prime, x1 prime, and I've got what else I have? I've got, that's for the first one, plus the second one, plus x2 prime, plus 0, plus 2x2 prime, plus, and last one, well, that was actually a minus. So minus x3 prime plus x3 prime plus 0. Okay, and what is that? That is going to give you a vector that's going to be actually x in the standard basis. This is going to give you the coordinates. This is going to be the x1 coordinate in the standard basis. That would be the x2 coordinates in the standard basis and the x3 coordinates in the standard basis. How do we get there on the other side in general? Well, we just have to factor by e1s. What do I have? I've got x1 prime alpha 1 1 plus x2 prime alpha 1 2 plus x3 prime alpha 1 3 times e1 plus some stuff for e2. I can factor with e2 and I can factor with e3. So x1 prime alpha 2 1 plus x2 prime alpha 2 2 plus x3 prime alpha 2 3, x1 prime alpha 3 1 plus x2 prime alpha 3 1 3 2 plus x3 prime alpha 3 3. Okay, this is it. So I've got a linear combination of the basis of the old basis vectors. These things here, they just belong to R. Okay, these are just real values. And the beauty of that is that actually, what do we have? This thing here, this xb. So what do we have? This is corresponding to, you see, you've got a linear combination of x1 prime, x2 prime, x3 prime. What do we have like this? We have alpha 1 1, alpha 1 2, alpha 1 3, and alpha 2 1, alpha 2 2, alpha 2 3, alpha 3 1, alpha 2 3 2, alpha 3 3. Okay, so this is what we've got. This is actually x in basis B prime, and this is what we're going to call the matrix P from B to B prime, okay? And we've got this expression, x expressed in basis B, so as linear combinations of E1, E2, E3, can be written as this matrix times the coefficients x1 prime, x2 prime, x3 prime. Okay, and what we can observe, the important thing is that this P B to B prime contains actually where alpha 1 1, alpha 2 1, alpha 3 1. This contains exactly the components in columns of each vectors of the new basis. Okay, so here something on the other side, you can write that x1, x2, x3, they are just going to be the matrix that we already talked about. 1 0 2. Why doesn't it write? 1 0 2 negative 1 1 0 times x1 prime, x2 prime, x3 prime. Okay, so that's it. That's the thing that we have. xb is p b to b prime x prime, and the nice thing is that this matrix is invertible. So if you want x prime, the new coefficients with respect to the old ones, it's just p minus 1 xb. What do you think comes here? Okay, p minus 1.